just made it. Front row seats even. I think we're going to start. What do you think? Yeah? If people are coming, is this too loud? No, it sounds very loud right here. Okay, good. All right, we made it. Yes. And some people are wanting to be downstairs. How great is that? So, anyway, welcome, welcome, welcome. It's so nice to see you for the annual meeting for 2023. I'm Abigail Brooks, for any of those who don't know me. I'm the president of the board, and really happy to see you all here. So this marks our 51st year protecting the rural character and natural resources of Little Compton for the lasting benefit of the community, following an amazing blowout last summer, celebrating our 50th. Each year, the annual meeting gives us an opportunity to recognize conservation-minded landowners, our membership's essential funding, and the services of hundreds, literally hundreds, of energetic, passionate, and dedicated board and community volunteers that have made it possible for us, this organization, to continue preserving and stewarding nearly 470 Little Compton acres in Rhode Island, in Little Compton, as the first private, nonprofit community land trust. I'll get my footing in a minute. So I'm going to give you some highlights of the past year, even though you got them in recent newsletters and in the membership mailing that we sent out, but they bear repeating. So as you know, stewardship, the yearly inspection and management of our holdings, continues to occupy a good deal of the work that we do. Our team of over 30 volunteers, ably led by our stewardship director, Adam Yorks, and joined this summer by a graduate intern from URI's Environmental Education Master's Degree program, continues to ensure we are responsibly handling the many challenges of protecting the conservation values of 79 individual parcels of land that we are protecting permanently from development. The continued implementation of a 5-year forest management plan on the Blanchard and Blazer properties that looks terrible, but it will get there, along John Dyer Road, where invasive control activities, as well as the planting and caging of more than 65 young trees, has taken place. With the help of the Little Compton Tree Committee, it's an amazing example of one of the more intensive land management projects that we have. Thank you to all of you who have been responsible for helping with that. We acquired an easement on an open field in December of 2022 belonging to Rush Taggart that adds over 2 roadfront acres to the 4.5-acre contiguous field that he, his mother, and sister protected with us in 2012. These 2 parcels permanently save an unimpeded view from West Main Road across fields and stone walls to the distant woodland edge of Wilbur Woods within a large block of previously conserved properties. And as I speak, we are in the midst of finalizing the details with 2 families on additional land projects that we are really excited about. Our new office on Simmons Road and its daily activities and functions are being managed by our extraordinarily talented and dedicated Executive Director, Joy Elvin, who recently elevated to this position as we shift administrative duties from our volunteer board to professional staff. And we've returned to our collaboration with teachers and administrators at our local school, bringing 5th, 6th, and 7th graders to Simmons Mill Pond and P.T. Marvel to learn about each preserve's natural resources and the species that make use of them. Our Laurie Richmond Goodnow Young Naturalist Award is given to an 8th grader each year with an exceptional interest in the natural world. These initiatives, coupled with our newsletters, movie series, and speakers, reflect our commitment, deeply held commitment to keeping conservation education as a core part of our mission. So that's the end of the activities, and I'd like to introduce our treasurer, Bill Terrio, to tell you about our 2022 finances. Where are you, Bill? Oh, there you are.
Okay, before I get into the numbers, a little background might be in order. So as many of you know, we've been engaged in a multi-year campaign to increase our investable assets to a level where the earnings on those assets cover the bulk of our operating expenses in a typical year. Unfortunately, there are very few typical years. 2022 was an example of that. So if you use the Standard & Poor's 500 as a proxy for the stock market, it was down about 18% for the year. That said, because we were fairly conservative investors and invest in a variety of CDs and index funds, we were able to have a better rate of return than the overall market, but it was still a down year. That's the bad news. The good news is, thanks to the success of our gala last year and continuing contributions from the folks in this room, we were able to increase our investable assets by $315,000 net for the year to a total of just over $2.3 million. So that goes a long way towards reaching our goal of covering our operating expenses. And a perfect example of that is our year-to-date results for 2023, where our investment earnings of approximately $100,000 almost entirely cover our year-to-date operating expenses of $110,000. So that's kind of the state of the union. If anybody has specific questions that they'd like answered, track me down and I'll do my best to answer them.
Yeah, he deserves applause. It's been amazing to have Bill on our board. He's just so competent. So then the next piece of business is that our membership, I'm going to ask you to vote on our officers and directors for the coming year. So I'm going to list them for you. Officers, Abigail Brooks, President. She just will not get out of the way. Sheila McIntosh, Vice President. Bill Terrio, Treasurer. Ann Beardsley, Secretary. And Directors Paul Bozzoni, Mikal Brownell, Herb Case, we'd like to invite onto the board, John Cook, Nan Haffenreffer, Maureen Hayes-Harrington, Warren Jagger, Jeff Manning, Jeannie McAllister coming onto the board, we hope, with your vote, Judy Melanson, and Peter Rowley. So may I have a motion supporting the nominating committee's slate of officers and directors for the coming year? A second? Any comments, questions? Not hearing any. All in favor, please say aye. Any opposed? Right, thank you. So before I introduce this evening's speaker, I'd like to thank our board members and staff for stepping up so willingly to assist with this event, to Clark Shear Media for taking on the videography for this meeting in the midst of welcoming their newborn son, Cooper, to the world. And the unfailingly helpful and friendly staff at the Little Compton Community Center, Chef David for his just marvelous catering of this event, and Karen Ferreira for her steady knowledge, organizing help. She's just wonderful. All of them ensuring the success of this evening for all of us. So this brings me to the close of the business part. So now I'm going to introduce our speaker, Heather Holm. At a gathering of a group of us working on plans for our Meehan Triangle project at the head of Taylor's Lane, the subject of my search for an inspiring speaker to address this annual meeting came up. Sue Theriault suggested pollinator conservationist and award-winning author Heather Holm. Our planning group has been sharing ideas about how best to manage this small, relatively invasive-free property to support the surprising number of native plants already there and the species of birds and insects making use of it. Landscaper Jeremy Allen, a partner in this project, recently said, "I see something new every time I'm there," and he's there a lot, mowing the paths and meeting with us about planning. We expect this experiment will serve as a potent demonstration for us and for private landowners of options for managing land to create and support habitat. Sue Theriault knew that some ground-nesting bees lay their eggs in the hollow stems of Joe pieweed, a ubiquitous wetland plant on our landscape that is thriving at the north end of the Meehan Triangle. She suggested we should time our cutting and the height of the stem we leave behind to accommodate that behavior. When I reached Heather's website following Sue's suggestion, there was no question that her areas of expertise align well with deepening our knowledge and practices on this demonstration project that we've been able to undertake with the funding assistance of the Aceves Family Charitable Fund. Please join me in welcoming Heather.
My laptop here. Well, thank you, Abigail, and also to Paul for hosting me. It's been such a pleasure to be here in Rhode Island and to see your community and to see all of the efforts that you are all undertaking to preserve land within your community. I do much of the same work, not professionally, but also as a volunteer in my own community, working on different nonprofits, and really looking strategically at how we can continue conserving very important and high quality land. All right. I said to Cameron he should have been waving his hands wildly in the background. I must have hit the cable as I lifted my laptop. So it's been a real pleasure to be here for a very short time and to meet many really passionate people here that are really dedicated to conservation. And tonight's presentation, my professional work really focuses on the relationship between native plants and the insects that the native plants support. And most importantly, those insects that are pollinating the native plants. This presentation tonight is also going to foray into other insects, and I was telling a few people this evening at the social, I hope this is not too much insect information for some of you. So fasten your seatbelts. So I'm going to talk about what are beneficial insects, and bees get folded into that category. And then you can see my very simple outline here. I am going to probably focus about a third of the presentation really showing you and telling you about native bees. And native bees are very different than honeybees. We saw some evidence, and we actually saw some native bees this morning when we toured the Meehan Triangle. And then I'm going to touch on some of these other insect groups just to highlight how they are beneficial and how they are providing various ecosystem services that actually benefit us and also the environment. And then I'm going to finish off by talking about things to think about if you are inspired and you want to plant various types of native plants to support some of these bees and beneficial insects. So first I'm going to define what the heck is a beneficial insect. And of course this is a term that humans have come up with, but essentially It is an insect that is providing some kind of ecosystem service, and for free, so we don't ask for anything in return. And many insects, of course, are pollinators of native plants. Either they are purposely visiting flowers like a bee would, or they may be incidental pollinators if they're other types of insects visiting flowering plants. And then the other sort of ecosystem service I'll be covering today is the free pest population control that we get from some of these native insects. So they're out hunting various types of insects, helping to keep pest populations that may be damaging plants in our gardens or the crops that we rely on growing. And so we really have to think about a little bit broadly about how beneficial insects can be. And we tend to focus on all the bad guys, and the bad guys or the ones that are really destructive or introduced or invasive insects. That makes up less than 5% of the total number of insects. So most insects are either benign or they are providing this one or more types of ecosystem services that do actually benefit us and the environment. And really the glue that sort of holds insects together, if you want a robust ecosystem, your foundation needs to start with a diversity of native flowering plants. Many of these insects have close specializations with native plants. And then those native plants in turn are going to support these insects. And insects, depending on what kind or what grouping they belong to, are visiting flowering plants for various reasons. Here I'm showing 4 different groups of insects on this slide: flies, wasps, bees, and beetles. These are all flower visiting insects. They're visiting the flowering plant either to consume pollen and nectar that the flower is offering. But while they're doing that, so if you can envision a diverse planting of native plants drawing in some of these flower visiting insects, where the beneficial insects come into play is they are lured in with your diverse planting, and then they are in turn going to perhaps lay their eggs on other types of plants in your landscape that may have a pest insect. So they themselves as adults may be the actual beneficial insect feeding on a pest population, or it could be, in some cases, their larvae. So you can see the various examples I have on this slide. The flower fly or syrphid fly in that upper left photo, that's an adult and a female, and she's busy consuming that flower's pollen in order for her to ingest protein from that pollen, and then she is able to produce eggs. And she's going to fly off from that flower patch when she has some eggs developed and go and lay them on a plant in your garden, for example, that may have an aphid population. So it's her offspring that are providing this ecosystem service of pest population control. So it's not always the adult, it could be a different life stage of some of these insects. But again, the glue that kind of draws them in and holds all the pieces together is this diversity of native plants. Today, when we looked and toured the Meehan Triangle, so even if you're looking at a natural area or the places that you may be gardening in your home landscape, you really want to think about how many different varieties of flowering plants you're growing, thinking about various flower colors. Do you have a flower restaurant essentially that is open 24/7 throughout the growing season? And this is critical because each of these insects that I'll be talking about today have very distinct time frames within the growing season that they are active. So you have to imagine your garden as this flower restaurant that needs to be open 24/7 through the growing season. That can be very tricky given our changing weather, our changing climate. If you hear you've had heavy amounts of rainfall, so that can change the timing of flowering plants, how long a flowering plant may bloom. And so just to keep monitoring your spaces, whether you're doing natural area management or you're thinking about how can I garden better for some of these insects, having something in bloom throughout the growing season. So I'm going to switch to talk about sort of the bees, which is going to make up about the next third of the presentation. And I really want to do a little bit of a deep dive so you better understand why I am so passionate about the native bees or wild bees that occur here in the US. So we have about 3,600 species combined in the US and Canada. Because Rhode Island, as you all know, is a very small state geographically, you have just over 250 bee species. So that's still pretty impressive. My home state of Minnesota, they just did an update, and we have 508 species. So you have half the number of bee species than my home state of Minnesota. Now, again, insects have evolved these various specializations with native plants, and that also includes bees. So you can see on that bottom part of the slide, 37 species, or approximately 19% of the 250 bee species that occur here in Rhode Island are pollen specialists. Pollen specialist bees are bees in which females just collect pollen from a certain kind of plant. So much like the monarch butterfly, the caterpillars just eat milkweed. In the bee world, the female mother bee just collects pollen from a certain kind of plant. So there are blueberry specialists, there are specialists of violets, specialists of goldenrods, and so having your garden also include some of these specialist plants is really going to help support some of these rarer bee species. Talking about what do bees eat. So this may seem pretty obvious because bees are out busy visiting flowers all the time, but it gets a little bit more nuanced once you start to become a bee or pollinator watcher. They're obviously visiting flowering plants for the two primary resources that flowering plants offer. The first one being nectar. You can think of nectar as being their sugar water, essentially, and that is providing their main source of carbohydrates. So while male and female bees visit flowering plants, they're probing that flower with their tongue, they're consuming nectar. The females are actually storing some of that nectar in an enlargement in their stomach called a crop, and then she will take that nectar back to the nest to combine with pollen. The nectar also has various types of minerals, free amino acids, secondary metabolites, so it's not just this really basic sugar water that we think about. And then pollen really is the most important floral resource for bee reproduction. So it is essentially their form of meat. It's their source of protein. It also has fats in it and other vitamins and minerals and amino acids. When we toured the Meehan Triangle this morning, I was pointing out some of the plants and the high quality pollens that they would be providing for various types of bees at different times during the growing season. And pollen, just like that flower fly that I talked about earlier, is essential for reproduction for the females and also helps with health and disease resistance. Now back to bee watching, if you've been starting to take a closer look at what types of what types of insects are visiting your flowering plants, a lot of the solitary bees will actually do a lot of pollen consumption while they're on flowers. So you can start to differentiate whether a bee is probing a flower with her tongue, or he is probing a flower with his tongue, or the female is actually consuming pollen to gain that protein source. And bees have various ways to collect pollen. So the females are the ones that are actively visiting flowers, purposefully collecting pollen, and then taking those resources back to the nest. The bumblebees and honeybees are the only bees here in Rhode Island that have this structure called a pollen basket, or the scientific name is a corbicula. And if you look at that left image of the worker bumblebee, the bumblebees are able to basically groom the pollen grains that adhere to the hairs on their body and then pack it on the lower part of their hind leg, which is an enlarged kind of smooth indentation surrounded by bristly hairs. So this is something visually you can start to see right away. I call them the orange footballs. They're really these distinct orange masses that either bumblebees or honeybees are carrying that pollen. Most other native bees that I'll be highlighting today instead have hairs of varying lengths either on their hind legs or on the underside of their abdomen. So just one bee family, the leafcutter bee family, has these rows of hairs on the underside of their abdomen. So take a look at that bottom right image. That is a leafcutter bee, and you can see that light pink pollen that she has on the underside of her abdomen. Similar strategy, these hairs are branched, and it's sort of the forked or branched hairs that help those pollen grains adhere to the pollen collecting hairs, and then the females can successfully take a pollen load back to the nest. Now, the anecdote, busy as a bee, is no exaggeration. So here's a really fun statistic, and this is in relation to bumblebees. So how many trips would a worker or queen bumblebee need to take to go out to flowering plants and bring back a pollen load or her pollen baskets filled with pollen just to feed one developing bumblebee larva within a nest? Well, it takes 18 foraging trips, and that's 2 pollen baskets, so that's a significant amount of pollen just to feed one bumblebee larvae. So they are very, very busy while they're trying to rear their offspring. Here is a look inside of a solitary bee nest that nests in a cavity. So you can see 3 bee larvae lined up one after the other, and the mother bee, in this case it's a type of orchard mason bee, you can see she has deposited a combination of pollen and nectar within each of those nice little rooms that she has created, and she has divided those rooms with mud. I'll be highlighting some other natural materials that these native bees use to either line or partition their nests. So this is the not so glamorous look inside of a bee nest. I spoke at a pollinator conference after a monarch presentation, and they were showing these wonderful photos of monarch caterpillars, and then I said I had to apologize because bee larvae are not that nice looking compared to monarch caterpillars. What's very interesting, we've always characterized bees as vegetarian, but more recently research is demonstrating that when the female is regurgitating some of that nectar that she stores in her crop, she is introducing beneficial fungi and bacteria into those pollen provisions. And it's the fungi that may actually be helping to ferment the bee bread or the bee food, and helping to break down those complex proteins. And the bee larvae may actually be consuming more of the bacteria and fungi than the floral resources, as we used to believe. So we're getting away from calling them pure vegetarian. Now, what makes a bee pick a certain plant? Paul was showing me some flowering plants in his garden this morning, and he was saying, I only see bumblebees going to this plant, but then I see these types of bees going to this plant, and they don't seem to, cross over. And there are a number of reasons why a specific type of bee may go to a flower. Bees have various tongue lengths, so if you just think of a flower structure that is not simple like the black-eyed Susan I have pictured here, a very complex flower is only going to be visited by perhaps a long-tongued bee. Second reason is a lot of these native bees that I will be highlighting have a very specific window of time during the growing season that they are active. So we have solitary native bees that come out in the spring that are active only for maybe the month of May, and then we have a completely different set of bee species that are active for the month of June. So obviously they are going to be visiting the flowering plants that are flowering while they're active as adults. They're also selectively going to native plants depending on the floral resources. So if you are a male bee, you would maybe be less interested in heavy pollen producing plants because you don't have an interest in consuming pollen or collecting pollen because you don't help with nest rearing activities. So it all sort of starts to parse out once you learn about bee diversity, the bee's specific seasonality, and you can obviously observe some of these preferences even in your home garden. There's a bit of a delay on my laptop versus what you're seeing, so just give me a sec. Okay, so back to pollen specializations. There really isn't a specific category, it's a range. So we have extremely narrow bee specialists, and they are called monolectic bees, and those females just collect pollen from a single plant species. So you can imagine how precarious her lifestyle may be. She's completely reliant on a single type of plant. She must emerge from her nest as an adult when that flowering plant is blooming. And so some of these very narrow specialists we think will be impacted by climate change because plants are sort of shifting around when they maybe historically flowered versus how much earlier or perhaps later they are now flowering. So this puts some of these pollen specialists at risk. Getting a little less narrow in specialization, we have a number of specialists that just collect pollen from a single plant genus. And then as you can see from this graphic, it gets more and more broad. And down at the bottom, the polylectic, or sometimes called generalist bees, typically are our social bees because they have a colony and individual workers and queens that are active in foraging throughout the growing season. So it makes sense. They have a much broader flower palette, and they're not specializing on a specific native plant. But for Rhode Island, I just wanted to highlight some of these host plants that you may want to think about. In early spring, and this is the case for most of eastern North America, willow is one of the most important plants for pollen specialists. In eastern North America, there are about 19 native bee species that just collect pollen from willow. And if you know where there is a patch of willow, it's a fun activity to go out in early spring while it's in bloom because it is literally a hive of activity. It's one of the first plants to flower, and you may spot some of these specialists. Two other really important plant families are the aster family and the heath or ericaceous family. We saw a number of ericaceous plants this morning in the Meehan Triangle, blueberries, and I'm going to ask Adam, what are some of the other ericaceous plants? Mailberry, and there was a third one, I think. Murdica, maybe? Bayberry? Bayberry, right, okay. So you have a prevalence of these early flowering ericaceous plants that are supporting some of these specialists. The aster family are sort of the late summer into autumn. Our goldenrods, our asters, all those wonderful blooming plants, and each of those supports a number of different bee specialists. So moving on to talking about what is the difference between honeybees and native bees. Honeybees they're an introduced species. So the first introduction that has been recorded was around 1630. So the Pilgrims actually brought honeybees with them to North America. Why in the world did they bring honeybees with them on a ship here to a new continent? Well, they relied on their source of honey as a source of sugar, but the more important thing that honeybees produced was wax, and they needed that wax in order to make candles. So early use of honeybees was really for individuals relying on the wax and the honey, but now they have become a large-scale agricultural pollinator. They often get sort of highlighted in the media and in the sort of general public understanding of what is a bee, but that couldn't be further from the truth because the native bees or wild bees that occur here in North America are very, very different. So the vast majority, about 90%, have solitary nests, so they don't create these social hives like a honeybee. Most nest in the ground, a minority above ground in various types of cavities. Our native bees have an annual life cycle, sometimes very short, 2 to 6 weeks. And our native bees don't produce honey. So some people ask me, well, if they don't produce honey, what good are they, right? Well, they pollinate 80% of flowering plants, and they specialize on a lot of these really specific native plants that need pollination in order to make our ecosystems diverse. And the minority, as you can see, about 10% of native bees are social. So that it does include our native bumblebee species. You have probably I'm just guesstimating 16 to 19 bumblebee species here in Rhode Island, and in addition, some of the types of sweat bees. So I'm just going to quickly talk about this if you're a gardener. So the social bees, people often ask me, well, how do bees overwinter? And then it's like, well, it's kind of complex because it depends on what kind of bee it is, what time of year you saw it. But in general, the social bees and the spectrum between social and solitary, but not solitary, these bees are overwintering as adults. So I'm going to talk about the bumblebee life cycle just to give you an example. So bumblebees have an annual colony. The colony is social like a honeybee colony. The big difference is our native bumblebees have very small colonies, just maybe they produce anywhere from 200 to 700 individuals in a growing season. The queens overwinter as adults, and they hibernate by excavating a very shallow burrow in the ground. And then in the spring here in Rhode Island, once the soil temperature's warm and flowering plants begin to bloom, those new queens come out of hibernation. They spend about 7 to 10 days looking for a place to nest. And I call this the Cinderella period because they are absolutely picky. They will investigate probably cavities in these wonderful stone walls that you have here in Little Compton. They may investigate an abandoned rodent burrow or chipmunk burrow in the ground. And they finally choose a place to nest. Once that queen has established a nest, she switches from visiting flowering plants to consume nectar to now begin collecting pollen to bring back to the nest. And you can see how disorganized a bumblebee nest looks compared to a honeybee colony. Basically, the queen is making large pollen masses, coating it with wax, laying multiple eggs on that initial pollen mass, and then incubating, much like a bird would sit on eggs to keep them warm, until those eggs hatch. And her first few broods within the colony are all female. So it's those females that are her workers or daughters that then can take over foraging in the landscape. So now we're sort of transitioning from early spring to summer. If you are a gardener, usually at that switching point when that first brood is produced is when you sort of start to visually see more bumblebees occurring in your garden and landscape. And then more and more going forward until the end of the growing season. The queen produces males following the first few broods of females, and their job is really to go and set up a territory or look for basically new queens coming out of the colony following the male production. So mating occurs in the fall for bumblebees, and sometimes a little bit earlier. You may even find mating bumblebees on flowering plants right now. And once those new queens have mated, then they disperse and then find a place to overwinter. So that whole colony, or all those bumblebees that we are seeing out in the landscape right now, will perish by the end of the growing season, except for these new queens that have tucked themselves under the ground to overwinter. So that's why their colony is annual. Don't worry, I won't spend much time on this slide. The solitary bees, on the other hand, and I'll be highlighting them for the rest of the bee part here, they, again, have a very specific window of time they are active. So the spring active native bees come out in the spring, obviously. They get busy and excavate a nest in the ground or find a nest in a cavity. Now here, getting back to the question, how do they overwinter? Well, most of them are overwintering in some life stage that is not an adult, other than a handful of species that are coming out really early in the spring. So most are sitting in the nest that their mother has created, and they will overwinter either in a pre-pupal stage or less often as an adult. Now, where do they nest? So how can you look for bee nests? The best time to look for ground nesting bee nests is in early spring. Today at the Meehan Triangle, we saw some small sweat bees, and they nest in the ground But in the middle of summer, finding a ground nesting bee, it's almost entirely impossible to find the nest, because think of all the dense vegetation. So if you get out early in the spring before vegetation really starts to come up, you may be able to spot various types of ground nesting bee nests. Some of their nests can look almost identical to anthills. So if you see a soil mound and perhaps a hole that is about the size of a pencil, then you may have perhaps a medium-sized ground nesting bee within your garden. Some are very picky about where they nest. So we have a number of native bee species that, for example, just nest in really loose sand. The other example I have here, some really like bare compacted soil. So they really look for specific places, whether it's a footpath in a park, a sandy sand dune here, or perhaps some are steering towards very heavy soils. And it all comes down to the specific type of bee. About 30% of the native bees then are above ground. And these are really easy to garden for, because you can provide a number of passive opportunities for these cavity nesting bees. So the female solitary bee, whether she's nesting in the ground or in a cavity, is going to collect pollen and nectar, combine those materials like that photo of the orchard mason bee nest that I showed you, deposit those until she has enough, and then she lays a single egg. So that's what my little graphic is showing. And then you can often tell what type of native bee is nesting within a cavity based on the natural materials that they use to cap, or sometimes you can see the partitions within the cavity. Native bees love standing dead trees. So thinking about if you have a larger property and it's safe to leave a standing dead tree, this can provide really important habitat. The native bees are using abandoned, usually beetle holes within the wood, and then they will come along and use those as nesting cavities. Similarly, logs lying on the ground. So these forested systems here in your area, a lot of wood lying on the ground. There's a number of native bees that really like sort of dry, rotting wood. The pure green metallic sweat bee is one that you can often find if you find a log that's at the right consistency and it has some opportunistic holes in it. You will find the metallic green sweat bee. You will also, as a gardener, can provide nesting opportunities in your flower stalks or plant stems. So I'm getting down in physical size of the bees I'm showing you. So these bees, the small carpenter bee, for example, is about the half to a quarter the length of your baby fingernail. So very, very tiny. And they are looking for either broken off flower stalks from last year's growth, or perhaps ones that you have cut a little bit high and left in place. And they will bore down the center of those flower stalks and make a nesting cavity. So many of the flowering plants that we grow in our gardens are not hollow. Some are hollow, but the ones that are not hollow have a styrofoam-like material in the center called pith. And so these small bees I'm highlighting on this slide are what I call pith excavators. So they actually chew out this long linear cavity within the flower stalk. And then they reuse that pith material to partition or create those walls in between the individual brood cells. So today at Meehan Triangle, we saw evidence of bees in this genus, and this is the leafcutter bee genus called Megachile. And the females of this genus can be identified based on the shape of their mandibles and the number of teeth. And you think, well, why is that? Why are they all have different shaped mandibles and teeth? Well, they're really these scissor-like apparatus, and the females land on the edge of a leaf, and then they literally cut a leaf piece, either in an oval or circular shape, starting from the leaf edge and sort of stopping at the leaf midvein. And she then carries that leaf piece back to her nest. So if you take a look at that bottom left image, she's got a curled up leaf tucked underneath her. And once back to her nest, either in the cavity or less often in the ground, she will overlap these oval-shaped leaf pieces to make that leaf cylinder that you can see on the bottom image. So she makes this extra envelope in order for her larva to rear inside. Then she often will go back to that same plant and make a circular cut, and that creates either the partition or the final cap on her nest cavity. So today at Meehan Triangle, we found some Carolina rose with the leafcutter bee cuts. So we didn't actually see a leafcutter bee, but it was an extra thing that we could observe and look for, knowing and then indicating that leafcutter bees were nearby. So what plants do they prefer? This is a short list. There is actually, if you are on iNaturalist, which is a community science platform where you can upload pictures of any living thing, including plants, insects, and everything else under the sun. There's a project on that platform that is collecting observations. So you just take a picture of a plant that you see the leaf cuts and add it to this project, and then researchers are accumulating a longer list than this 2016 study to better understand what types of plants the leafcutter bees use. Today, again, we saw it on one of the wild rose species. Red bud is very commonly used. You may see cuts on sumac or ash trees. In my area, ash tree seedlings that are still surviving post emerald ash borer tend to be heavily cut with leafcutter cuts. And other natural materials. So busy as a bee, I can't exaggerate. So in addition to finding all that food and going to flowering plants to, put in the nest to feed their offspring, they are going to all of this extra work and expending all this extra energy in foraging trips for these natural materials to line and partition their nest. So this is a picture of a mason bee in the same family as the leafcutter bee, but instead of using whole pieces, the females will again land on a leaf and start chewing from the edge, and then she chews up and masticates the leaf pulp, and that's what she uses to cap and partition her nest. Now, getting into a really sticky situation, we have native bees that actually are reliant on plant resins. And an example here would be pine saps or pine gum. And can you imagine trying to work with that sticky material as a little tiny bee, carry it back to the nest, and then apply it on the walls inside of your nest? But many of these natural materials have antimicrobial properties. So there is a little bit of method to the madness for why they're choosing these materials in the nest. This is a graphic I developed with some other bee folks, and it's just to better explain, going back a couple of slides, when I talked about those stem nesting bees. This is something you can do in your home landscape. So when you cut down plant material, you can leave anywhere from 8 to 20 inches of last year's flower stalks. This is a visitor center on the Mississippi River. The volunteers maintain this garden. So they started to experiment with leaving these various old flower stalk stubble. And this actual cutting, or you creating this stubble, provides some passive and opportunistic places for these cavity nesting bees. That graphic is available to download from my author website. So if you want to learn more, it explains from the plant point of view and the bee point of view what's going on during the growing season. Now, switching over to some insects, and I told you, fasten your seatbelt. So maybe some insects that you maybe don't have fond feelings about. So my most recent book, I covered flower-associated wasps and looking at what is this relationship between wasps and flowering plants. But I really learned a lot researching and writing that book, again, about plant specificity and also prey specificity. So all of the wasps out in the landscape, less than 2% are going to want to sting you. So a very, very small minority of wasps have a social nest, and it's the social species that will defend their nest if you accidentally disturb it. So 98% of wasps are out doing their thing in the landscape, in your garden, in your yard, and they don't have any interest whatsoever in stinging you or defending their nest. So they go largely unnoticed, and wasp diversity is absolutely outstanding. But what my slide is showing here is the non-social wasps have very specific prey that they hunt. So Paul was talking about his brother as a child capturing eastern cicada killer wasps, and how amazed he was because these giant wasps his brother would bring home in a container. And those large wasps exclusively hunt cicadas, and so on and so on. So here is where beneficial insects, or wasps, are considered beneficial insects because they actually provide two critical ecosystem services: some plant pollination through their incidental visitation to consume nectar, and then this large-scale pest population control. So if we remove wasps from the landscape, we would have insect populations just go way out of balance. So we have to think about wasps a little more fondly. And let me convince you. So here are some photos of some solitary wasps that you may see visiting flowering plants. And they can be large, they can be brightly colored, they can act rather erratically and seem aggressive, but they are simply at the flower restaurant sipping on some nectar to fuel their either mate or prey searching activities. And so just think about not being as concerned about any kind of wasp and any kind of bee while it visits flowers. Now, much like our native bees, our wasps are nesting in different places. We do have cavity nesting wasps, so this is just an example from a large subfamily called potter and mason wasps. And so you can see the natural material of choice for this mason wasp is to use mud. So she has to actually find a very specific type of soil and a source of water. She combines those two materials together, and she not only is out actively hunting various types of caterpillars to feed her offspring, she's collecting that mud in order to seal her nest. So you can see a very similar strategy, and these wasps are actually the ancestors of bees. So they instead are feeding their offspring some sort of meat or protein in the form of an insect or spider, whereas bees diverge from these wasp ancestors and have switched to feeding their offspring this completely plant-based diet. An example of a ground nesting wasp. This is a sand wasp, so over on some of the sandy dune sites within Rhode Island, you probably find large nesting aggregations of this wasp. They are called sand wasps because they only nest in loose sand. And the females, they're active usually in July, and they only produce one generation per year, so that means the time frame between a female lays an egg until that egg emerges from the nest as an adult is 12 months. And they are just absolutely amazing excavators. So they often form large nesting aggregations in sandy spots. And here's an example of prey specificity. The females just hunt various types of true bugs, and that includes stink bugs, shield-backed bugs, assassin bugs, and leaf-footed bugs. But then more recently, some researchers were tracking the types of prey that these females were bringing back to their nest, and they have also picked up and they've started to hunt the brown marmorated stink bug, which is an introduced invasive insect. So if the introduced insect belongs to a similar family or genus to the native prey that these wasps hunt, they will often also hunt the introduced insect. So that is also the case for the emerald ash borer. We have a native wasp that's switched to primarily hunting the emerald ash borer because it hunted wood-boring metallic beetles in the same family as the emerald ash borer. Okay, social wasps, yes, they will sting. Here in the northern U.S., in most of the U.S., they build their nests with paper. So if you see a nest made of paper, that is your indication that it is a social nest. And paper making, like mud making or leaf collection, is a process, which I won't talk about, but they are also very industrious. Paper wasps are the least aggressive of the social wasps, so they will build single comb nests without a nest envelope, usually attached to a horizontal surface. That can include the overhang or soffit of our sheds or houses sometimes, but they are less likely to be aggressive around their nest. They are considered beneficial because they primarily hunt caterpillars, and that can include really effective pest population control in vegetable production systems. So they will hunt cabbage loopers, tomato hornworms, and fall webworms. So that is a female capturing a caterpillar on a leaf. And instead of stinging their prey like the solitary wasps, the social wasps basically just capture their prey and then start chewing it up to immobilize it. So it's a little gruesome to watch, but that's what they're up to. I'm gonna touch on the last group of wasps, and I'm really just skimming the surface about wasps because I know you don't want a whole evening on wasps. But the most diverse groups of wasps are called parasitic wasps, and they are more primitive than the nest-building wasps. And they don't have a nest. The females either have a very short or sometimes an elaborate long ovipositor that looks kind of like a stinger. And they inject a little bit of venom and their egg right into their prey. So how many of you can think about how small an aphid is? Have you seen an aphid on a flower? So this little aphid wasp, I thought, is an example of a pretty small parasitic wasp. She's dancing around on the underside of this plant that is covered in this aphid population. And you can see in that bottom image, she's got her abdomen stuck out underneath her, and she's poking that aphid with her ovipositor, inserting her egg into the aphid. So her larva, once the egg hatches, will consume that host internally as it develops. So essentially killing it eventually. So back to the plant in my garden that I was watching this aphid wasp, and the picture on the left is the leaf right when around the time I saw the aphid wasp. And then I went back a week later and I turned over the plant and look at those aphids. Those are called mummified aphids because they have been parasitized either by that wasp or some other type of parasitic insect. So those aphids are all bloated and about to die because some other insect is killing it. So keep the pesticides on the shelf. You have a whole ecosystem happening in your garden if you just go out and start scouting and looking for these things. It's absolutely amazing. Similarly, you probably have seen various types of ladybird beetles, or also called ladybugs, but they're actually a beetle. And we have amazing diversity of ladybird beetles. Some are in steep decline. I don't think there are many researchers have an answer, but some of the introduced Asian ladybird beetles are causing the decline of the native species. They are predatory both as larvae and as adults. And you can see the picture of the larva on the bottom image. They kind of look alligator-like, and they will crawl around on plants with various pest insect populations and voraciously consume things like aphids, scale mites, whiteflies, and so on. So they are really fun to look for if you're out scouting your plants. While you're scouting, you may see these caterpillar-like things, and they are in fact a type of fly larva. So the syrphid or flower flies I talked about at the beginning that are, they sort of mimic bees. People often mistaken them for bees. They're regular flower visitors. So again, that flower patch that you have in your garden is to bring them in. And then the females are going to lay their eggs on various other plants in your garden. The larvae, again, look caterpillar-like, but much like the ladybird beetle larvae, are voracious consumers of various types of pest insects. Last insect, don't worry, I'm done with the insects, is there are two families. They're types of lacewings, the brown and green lacewing. And these are really beautiful insects. Green lacewings are on the wing, probably some of the earliest insects that I see in early spring. They overwinter sometimes under leaf litter, so that's just to throw that out there. Really tidy gardens don't tend to support as many beneficial insects because we tend to clean everything up and we're really taking away a lot of that overwintering habitat. The green lacewing females, that top image is a picture of her egg. So she's pretty unusual. She lays her egg often on a plant or a flower head, but then the egg is suspended by a silken thread. So see how it's sticking up almost like a balloon. And that's a single egg, but often you will find a cluster of those eggs that have been laid on a plant. So another thing to scout for. Once those eggs hatch, the larvae look kind of similar to the ladybird beetle larvae. They're alligator-like, and they crawl around on your plants, and they do a lot of work consuming a lot of pest insects. That poor mummified aphid on the left is not only dying from a parasitic wasp, but now this green lacewing is really going to finish it off and get an extra wasp protein meal while it's at it. How do we plant for these really cool and interesting insects? Well, just to narrow it down a little bit, I thought I'd highlight some of the top plant families. So unlike bees that I talked about that have perhaps really long tongues and different foraging seasons and have to go to flowering plants for their primary food source, these beneficial insects supplement sort of their activities by visiting flowering plants to either consume pollen and or nectar. But most of them have very short mouth parts, limited seasonality. So these flowering plants, for the most part, have shallow, accessible flowers. They are blooming when most beneficial insects are active, and most of them are nectar producing, which the beneficial insects are looking for. So just to highlight a couple of these families, the aster family, a lot of those late summer, autumn blooming plants that are easy to incorporate into gardens, the well-behaved goldenrods, the asters, bonesets, black-eyed Susans, and so on are very good at supporting beneficial insects. The mint family are also great. Mints are generally visited by most insects for the nectar. So bumblebees love things like wild bergamot with that more complex flower structure that suits their long tongue, and they're able to access those resources. But hands down, if you want to start with just one plant, your take home tonight, plant some kind of mountain mint. And I think you have at least 2 species native to Rhode Island. That is an absolute beneficial insect, pollinator palooza plant, I would call it. So get out the lawn chair and hang out by your mountain mint once it starts to bloom. The milkweed and dogbane family. So you cannot go wrong by planting various types of milkweed native to the area. Today at the Meehan Triangle, we saw these 2 species. If you have a variety of different milkweeds, then you're going to have them blooming again to help fill out that flowering phenology. Milkweeds just offer nectar to insects, surprisingly, because their pollen is packaged into these very sticky sacs called pollinia. And the flower relies on very strong, large insects to snag their leg on the filament hole, holding these sticky sacs and transporting the pollen that way. So bees or other pollen-interested insects are not visiting milkweed for pollen. Okay, let's take a step back, or maybe a 100-foot view of the landscape, thinking about if you have a vegetable garden, would you like some of these beneficial insects to help you with attacking and hunting some of the pest insects you have in your vegetable garden? Well, we have to think about how we can facilitate movement for these pollinators and beneficial insects. We need that diversity of flowering plants that's going to bring them into the landscape, to keep them in the landscape. We need the appropriate types of nesting habitat nearby, and then perhaps having that planting near your vegetable garden is going to help facilitate some of this pest insect population control. But we can't have these three components spread way apart because many of these insects really don't fly very far. So the closer to the better, the more integrated you can think about your landscape, the more ecosystem services you will get from these insects. Thinking about where's a starting place to put in some pollinator habitat in a home landscape. My friend Leslie Pilgrim came up with this idea. She's sort of a marketing background, but she said, there's an entomologist, Doug Tallamy, who has written numerous books and talks about the benefits and the relationship between native plants and moth and butterfly larvae or caterpillars, specializing on native plants. And Doug Tallamy is a big proponent of people to plant plants called keystone plants. And keystone plants are plants that support a very high number of butterfly and moth caterpillars. So back to my friend Leslie, she said, okay, Doug Tallamy's telling everybody to plant keystone trees, but what happens when these caterpillars are ready to pupate? Many of them will leave the host plant and go somewhere else. And if we're planting all these trees in our landscapes with turf grass underneath, we're not providing that really important habitat for these butterfly and moth species to complete their life cycle. So she came up with this concept or term called soft landings, and I've been helping her promote this. And you can find out more about it on my website as well. There's tons of handouts and information. But the idea is getting plantings underneath trees. People don't like mowing under trees. Turf grass typically grows poorly under trees. So this idea that we're creating this sort of landing platform for those caterpillars when they leave their host plant to finish their life development. And here's an example of what could be a larger scale soft landings. So this is from the University of Illinois campus. They've been converting a lot of unused turf grass areas on their campus and putting in this sort of what we would call a soft landings planting. And soft landings plantings, the plants that we're recommending are many of our different native sedges, which look grass-like, low-growing, flowering perennials. And so just having this more soft and attractive place underneath a tree is a great place to start if you're thinking about pollinator habitat. Looking at the trees planted across the street from the community center before I was introduced, and there's turf grass growing under these. So this idea is really catching on. University campuses are starting to try soft landings plantings. Conservation organizations, municipalities are, reducing the number of unused turf grass places in parks. So this is just to think about where to start if you don't know where to start, and it could be a really useful solution, especially if it's under a native keystone tree. All right, wrapping up, thinking about habitat. So I really am a proponent of passive habitat. You may have seen pictures or things called bee hotels where people are building these elaborate things with stems and all this other stuff to provide nesting opportunities for cavity nesting bees. Don't go to all that work. A lot of you already have these places that already are natural habitat, and then you can start to experiment by adding things like some stem stubble in your garden. And the next step is to watch and see what happens, because if you just leave one plant with some stem stubble next spring, keep an eye on it. Maybe you will start to see the pith shavings coming out of the tops of those cuts that you left in your garden. And lastly, that flower restaurant needs to be open 24/7 through the growing season, but it also needs to be pesticide free. So if we are going to create these diverse habitats for pollinators and beneficial insects, we cannot continue to use pesticides while these plants are in bloom, especially. So the more you can live with some holes in your leaves, because those holes might be the work of leafcutter bees, the more you can tolerate a caterpillar's eating a plant, because that caterpillar is going to turn into a beautiful butterfly or moth, the less you will need to use pesticides. So we have to really think mindfully about these toxic chemicals. So not really leaving on a positive note, but thank you so much again for all that you care about and keeping your community natural and beautiful. If we have time, I'd be happy to answer questions. I'll just look to you, Abigail, for. Okay. Right. Right.
Or whether swallows actually do feed on bees.
That's a good question. So Abigail says she has a linden tree, and when it's flowering, she saw swarms of swallows flying around and wonders if the honeybees are being consumed by the swallows that are visiting the linden flowers. So we talked a little bit about this on our drive down here. In early spring, I've observed many different songbirds eating bees. Back to that willow and standing by a willow while it's in bloom, and it's just this hive of activity of solitary bees flying around the willow. Well, the chickadees know all about this, and so do some of the warblers that migrate through my area, and they hang out on trees and they watch all this activity and they eat the bees. So it's possible, because swallows, they eat a lot of different insects. They may be hunting the honeybees while they're on the linden tree because they're so concentrated, but you have to hang out and maybe confirm yourself. So I don't have a good answer, yeah. But it's not uncommon for birds to eat bees, yeah. And they tend to somehow know which are the male bees, which don't have a stinger, and which are the females. Yeah, so I've seen them sort of selectively picking off the males. No offense to the males in the room, but that's what I saw. They call them sweat bees, and it's a whole family of bees because they have a tendency to land on your arm and consume your sweat. So they're looking for the minerals that we are producing in our sweat. So I always say look before you swat because some of them are quite tiny and they'll land, and just take a look before you swat because they kind of tickle, but they're not going to sting you. They are persistent, though. I don't know how many times I've been like, go away, that's enough sweat for you, and then they come back. So, but that's why they get the common name sweat bee. Yeah. Yes.
Is that natural, the holes? Is that the mason bees, whatever they make those?
No, those holes were probably created by beetles. So the larvae are wood boring and then emerge as adults, and then they create these cavities for some of the bees like that. So the only wood boring sort of bee that will create its own cavity is the large carpenter bee. The large carpenter bee. They look like bumblebees, and you have them here. Yeah. Of all the cavity nesting bees, that is the only bee that is sort of considered destructive because it likes human buildings. So.
We're always good at providing habitat for the mason bees.
Right.
So I was looking at that trunk and I was thinking, is that something that we could do if we had a dead tree? We went up with a drill and made lots of holes with that and invited mason bees.
Yes, you can do that. That would be more hygienic than the bee hotels or tubes that you talked about. So she asked, I have standing dead trees, what if I drilled holes in them for some of these bees? So the mason bees, some of the medium-sized bees, which are about the size of a honeybee, they like holes either somewhere between 3/8 of an inch and at the largest a 1/2 inch in diameter. But you need a really long drill bit, so don't drill 1-inch holes. You need a really long drill bit. Yeah, so you want that hole to be as deep as possible so that that bee can have many larvae developing within it. If you did a really short hole, you have 2 bee larvae and the woodpeckers or something else is going to kill those because it's so short. Yeah. So look for a long drill bit.
Are they declining because of the timing when things come into flower? And if so, is it beneficial to do like a Chelsea chop to some of the, flowering plants so that you can change the progression of
Right. So sort of 2-part question. The first part is climate change and when flowering plants bloom and how that's impacting certain bee populations. And then the second part is doing something like the Chelsea chop, which is cutting your perennials down in early July. Is that when you typically do? June? Yeah. It's named after the Chelsea Flower Show in Britain. It's a British practice, but you cut your perennials down while they're growing, and then you can stagger the bloom times and also keep your plant shorter. And that is a great idea. So if you had a large patch of one type of perennial, you could Chelsea chop half of it, and now you've just expanded that flowering period for that specific plant. And that is probably going to be helpful. I'm in Minnesota where I am. I know you guys have had tons of rainfall. We are in a drought. So what is happening in a drought situation is plants are blooming for a very, very short period of time. So a flowering plant that would maybe flower for a week or more is flowering for a day and a half because of the drought. So there's all of these climate change related impacts to plant stress, the resources that the plants can provide, how long they bloom. So anything that we can do, like the Chelsea chop, to sort of keep our gardens flowering as much as possible is a great practice. There is no effective way to get rid of them. So some researchers have experimented with putting up sort of a board of the similar type of wood that they seem to be attracted to on your house or whatever structure. And then once you can convince them to move to that wood, then you can move it and take it out of your yard. So it's almost like creating a wood sink in similar conditions and hoping that you can trap them there and then move them elsewhere. But yeah. So convincing them not to nest on your deck railing or whatever place they're causing problems, and trying to get them to providing a different place that's not going to impact your structure instead. And they've had some success with doing that. So that was in Maryland. So, but I don't have. In fact, we don't have large carpenter bees in Minnesota yet. Their range keeps expanding. So any day I will see them in my home state. But yeah, they can. Yes, they are absolutely beneficial. Yep, they're very good pollinators of plants, and they're just annoying because they impact our human structures. So.
For a parcel of land to support native pollinators. Maybe right now it has a lot of non-native weeds, or it's degraded in some way. How do we assess like where we can get it through management or planting?
Yeah, it's a tough question. So with any restorations I work on, the primary goal is increasing plant diversity first, taking out invasives, of course, which I know that's what you're doing, Adam. And then, kind of like what we talked about this morning, then I start to evaluate. Once you start doing a plant inventory, you can start to evaluate that plant inventory for what plant families are represented, bloom time, and then you will start to see where you have gaps, and you can think about, how do I get some of these plants that are missing back into this landscape? So That's usually my approach, or if I'm starting from a heavily degraded site that has no native plants, I'm heavily seeding it and then tracking it over time to see where do I have gaps and what do I need to augment the site with. So it kind of depends on your starting point, I guess.
A wonderful presentation. We have a new phenomenon around here called jumping worms, which may not be in your.
We have jumping worms in Minnesota.
Is there a natural predator or?
No,
unfortunately.
So the new idea with jumping worms is to change the conditions that they're thriving in. And so they are thriving in moist conditions in forests. So where I am in the Midwest, we are thinking about how do we turn those spaces into more open habitat that gets more sun, that dries out more, and is more of a grassland system. And there is just some early research being done on that, so I'm just throwing it out there. But with a lot of these invasive insects, they are thriving because of the perfect conditions we are providing them, and that includes some of our invasive plants. So thinking about how do we not offer up so much of the conditions that they love. And from my understanding, they live in pretty much the top inch or two of the soil. So that's one of the reasons why when the jumping worms are in Minnesota, but we don't find them in prairies or more open habitats that are sunnier. So thinking about your home landscape, drying it out somehow, which is almost impossible with your rainfall events, but where are they thriving now in your home landscape or where you've seen them, and then thinking about how can we sort of alter those conditions would be my, but no, there's no, the genie is out of the bottle on the jumping worms, unfortunately. The earwig, I don't, it probably does, but not in my wheelhouse of insects, but it most likely, oh really, you have earwigs on your flowering plants, interesting, okay. Okay, well, I would assume there is some insect parasitizing earwigs and doing its thing, so I don't think of any living organism that doesn't have a natural enemy, but I don't know the answer. Fantastic. Well, thank you so much. It's been a pleasure to speak with you.